Okay, so this one is a division, right? Although you're not seeing the symbol too well, this one is mixed numbers again, but this is a division. So I want to do 4.5 divided by 2.25. And again, we have mixed numbers. Now, I want you to pay attention to this. Just now, although we did addition, right? Division, the process of dividing mixed numbers is slightly different from addition, where you don't have to get an LCM. What we actually need to do here is convert our mixed number into an improper fraction. You remember what an improper fraction is? You can remember what an improper fraction is? So right now, this is a mixed number, right? And I could also tell you that a half is what we call a proper fraction. So what do you think something called an improper fraction might be? What's your thoughts? Any thought?
Fractional number
What happened to your number?
is greater than or equal to the denominator.
Right. So whenever you have an improper fraction, it means your numerator might just be a bit bigger or about equal to the denominator, right? So that's possible. So what we're going to do now is create improper fractions, meaning that the fractions that we're going to change these into, their numerators are going to be larger than the denominators. Do you remember how to convert a mixed number into an improper fraction? Yes or no? Do you remember how to do that?
Yeah.
Yeah? Okay, well tell me. What are we going to do? If we want to convert 4.5 into an improper fraction, what do you think you're going to do?
Divide 4 and 2.
I think you have the right idea how to do something with 4 and 2, but think about our next operation. How can we make a larger number with 4 and 2? Okay, so think about this.
Divide it.
Think about this instead. If I tell you I have 4 packs of snack that have 2 in it, right? You know how sometimes you see what you call these things, like gumballs. You know, just have little packs with the gumballs, and sometimes just have packs with like 2. So if I have 4 packs with 2 gumballs, how many gumballs I have in total?
2.
So each pack have 2 in it, and I have 4 packs with 2. How many we would have if we empty out all 4 packs? How many gumballs would we have?
None.
Well, there wouldn't be any pack anymore. But what I mean to say is, if we put all the gumballs, take it out of the pack and we put it in a bowl, right? I have 4 packs, where 1 pack have 2. Each pack has 2. Think about that a little bit. So let me just draw it out a little bit, right? So just pretend this is your 4 packs here. Right, you have 4 packs. I'm going to empty out the 4 packs in a little bit. How many are say in each pack?
4.
How many each pack have?
2.
2. Right? So each pack has 2. So let's have 2. How many does pack have?
2.
2. How many does pack have?
2.
2 again. Alright. How much do you think this pack have?
2.
2 again. Alright. Now add it all together for me. How many we have in total? Four packs of 2 would be how many in total?
8.
8. Correct. 8. So, tell me, what can we do with 4 and 2? What operation can we do with 4 and 2 that we will get 8?
Multiply.
Multiply. There you go. Multiply. So multiplying is part of your process to convert your mixed number into an improper fraction. So what you do, you multiply the whole number by the denominator. We said 4 by 2 is 8. And then when you multiply those two numbers, what you're going to do is add that to the numerator. So what is 8 plus 1? What's 8 plus 1?
1.
You're adding 1 to 8. 9. There you go. So multiply the whole number and then add the numerator. That would give us 9 over 2 for this fraction, right? I want you to do the last one from 2 1/4. Do that one by yourself for me. What do you think you'll get? Mm-hmm. 2 by
8.
right. 2 by 4 is 8. Good. And what we doing with the 1?
Add.
Add. Very good.
9.
9. So now we have 9 over 2 divided by 9 over 4. Okay. So do we do division now?
Yeah.
You serious? We're going to do it. How is divide fractions? How is divide fractions? Always do. What's supposed to do? Tell me. I'm going to say 9 divided by 9 is 1 and 2 divided by 4 is 2. I'm going to say that?
No.
No. So we're supposed to do something else before we work this out. What we going to do? Alright. Alright. You know what's KFC?
Yeah. KFC. I'm not touching.
We're not talking about the fried chicken, right? We're not talking about it.
KFC chicken.
Yeah, we're not talking about KFC chicken right now. We're talking about it with fractions. What does keep mean? When they say you're keeping something, what it mean you're doing? You're keeping it, right? You're not throwing it away. So you have it somewhere. So I want you to keep the first fraction as it is, right? So we're keeping this fraction as it is. So in the next line, if we keep in 9 over 2, and the next time we're going to keep the 9 over 2 by writing it back, right? We're keeping it just like that. F stands for flip. What do you think flip means? If you flip something, what you do with it? You ever flip a table? Flip a chair? You ever flip? You ever play a board game with somebody? Like Ludo or something? You ever play Ludo? Or Monopoly? And you find like you wasn't winning and you get vexed and you just tip over the board? You ever do that? So when we say flip, we mean to turn over, right? So we're going to turn over the second fraction. Right? So when I say flip, I mean to turn over the second fraction, right? So you could turn over this fraction for me. Flip this fraction. What would you flip it into? So if we turn it over, what I want you to do is write the denominator on top and write the numerator on the bottom. So right now the denominator is 4, so we're going to put that on the top. So what would that look like? So if we flip this, what would it look like?
4.
Uh-huh. Over what?
2.
What's the top number in this one?
9.
9. So it'd be 4 over 9, right? So we keep the first fraction as it is, 9 over 2. We flip in the second fraction, so that's where the 4 over 9 come from. And the last letter is change, right? Change. So we're going to change something. Well, we didn't talk about the operation as yet. but the operation is where we change it, right? So we're going to change it. What's the opposite of division? What operation you do where you have to get your timetables? What operation is that? You can remember what we said earlier? What operation we do here when we say we were converting the fractions and you had to use your denominator, and your whole number? So we change the division to the operation it is opposite to, which is multiplication, right? So we have our statement that we're going to work out now. And to work this out, all we have to remember, after we make our adjustments to suit, we have to remember numbers that could go into other numbers. So we need to remember factors. So if I look at this fraction statement, right, we did something what we call the butterfly method, where we reduce the fractions on the diagonals, right? We reduce the numbers that are on the diagonals. So this is what it looks like, right? Butterfly method. And what we say is, in this case, since these numbers that are opposite to each other, both of them are 9, what number could go into 9? I could think of at least 2 numbers, right? So you could use 3, but you could also use 9, because 9 is the higher number, the higher factor that will go into both of them, right? So we say 9 into 9, 1, and 9 into 9, 1. And then on the other diagonal, we have 4 and 2. And I'm sure you could think of a number that could go into both of these numbers, right? So 2 could go into 2 once, and 2 could go into 4 twice. From here, we're going to multiply the numbers in the numerator. So 1 by 2 is 2. And then we multiply numbers in the denominator. 1 by 1 is 1. And if you could remember from the last time we would have dealt with fractions, we said that anytime a denominator is 1, this means that this is a whole number. So our answer here is 2. Right? So we'll just write that for our answer. Our answer is 2. So remember, whenever you're working with mixed numbers in the division, remember to change your mixed numbers into improper fractions, right? After you change it into improper fractions, you're going to use this little KFC method. Do think about chicken while you're doing it, right? You could think about it and say you're going to reward yourself if you could get through all them fractions questions, right? So KFC meaning to keep the first fraction as it is, flip the second fraction, and change the sign to multiplication. Then, after that is your butterfly technique. You break down the numbers on diagonals. Yeah. And then, that's your answer. Right? So it's 1059. It's 1059.